Welcome to Zaption Tour 7-4, Division Properties of Exponents. There are 6 boxes. So the essential understanding here is you can use the properties of exponents to divide powers with the same base. So far we've been talking about how to multiply powers with the same base. Now we're going to divide them. So here's the first box, and let's talk about why it works. Let's say I want to take 3 to the 5th, and I want to divide that by 3 squared. Well, remember that 3 to the 5th just means, 3 times 3 times 3 times 3 times 3. It just means 3 times itself 5 times. That's what 3 to the power of 5 means. Well, if I divide this out by 3 squared, I get 3 times 3. And we all love to do this in middle school, was when we have a number on the top of a fraction that's the same as the number on the bottom of a fraction, and we are multiplying, then we are allowed to cancel out because they make a factor of 1. 3 divided by 3 is 1, 3 divided by 3 is 1, and what we're left with is just 3 to the 3rd on the top, 3 to the 3rd on the numerator. Notice that in the denominator I only have 1 down here, so you could write it as 3 to the 3rd over 1, but nobody writes it like that anyways. So what we end up with is just 3 to the 3rd. And some of you might be able to see right away that if I just take the number 5 and the number 2, is there a way that I could get the number 3 out of this? Obviously there is. If I just take 5 and subtract off 2, I would get 3 to the 3rd. So the rule simply says this. If I'm taking a power, or the base of a to the power of m, divided by the base of a to the power of n, it is the equivalent of the base of a to the m minus n. I think most of you have seen that before. If not, here is the formal rule. Let's do 2 examples together in box number 2. Example A says m squared n to the 4th over m to the 5th n to the 3rd. So what we want to do is write this as, okay, well this is m to the power of 2 minus 5 multiplied by n to the power of 4 minus 3. It's always the numerator subtracted from the denominator. Well, 2 minus 5 is negative 3. So that gives me m to the negative 3. That's okay for now. And then this is just going to be n to the first power, because 4 minus 3 is 1. Now, m to the negative 3, because this is a negative exponent, we learned earlier that it's going to move to the bottom of my fraction. So your answer is going to be n all divided by m to the 3rd. Notice that I did not need to write the 1 on the exponent of the n. It's not customary. Okay, part B says x to the 5 halves minus 2. So even though this is a fraction, it still works the same way. So this is x to the 5 over 2 minus 2. So now I have to take 5 halves and subtract 2. Well, that's the same thing as x over 5 over 2 minus 4 over 2, right? Because 4 divided by 2 is the number 2. So I've changed my fraction to a common denominator. And then 5 halves minus 4 halves just gives me x to the 1/2 power, or equivalently, we could say this is the positive square root of x, but we don't need to write that. The book for this answer would probably just give you, or for this problem, just give you that one right there. Okay, box number 3 is a you try. I want you to simplify and write without negative exponents. So make sure there are no negative exponents in your answer. Okay, hopefully you got the right answer. If not, we begin by taking the base of a and subtracting negative 3 minus 5, because I have negative 3 over here, minus 5 in the denominator, multiplied by b to the 7 minus 2. And so negative 3 minus 5 is negative 8. 7 minus 2 is 5. So because I have an a to the negative 8th, it's going to move to the denominator of my fraction. So the solution should be b to the 5th over a to the 8th. Box number 4 is raising a quotient to a power. So the quotient here is what's inside the parentheses here. Oh, sorry. The quotient is this x divided by y. That is my quotient, and I'm raising the entire quotient to the power of 3 because the 3 is on the outside of the parentheses, and it is being applied to both the x and the y. So what this means is this. This means that literally x over y times x over y times x over y, right? 3 times. You take whatever's inside the parentheses and you multiply it by itself 3 times. Well, notice that just gives you x times x times x, which is x to the 3rd, because when we're multiplying our bases, we add exponents. That was way back in lesson 7.1. And then the denominator, I also get y to the 3rd. So notice that if I am raising a quotient to a power of 3, the 3 gets applied to both the x and the y, okay? Many students, when given this problem, x divided by y to the third, will simply just write this, x to the third over y, and hopefully you see that that is not correct, okay? So the rule says this: if I take a quotient, a over b, and raise it to the nth power, it is the equivalent of raising a to the n divided by b to the n. Let's do 2 examples for box number 5. It says x to the 2/3 divided by 5, all raised to the third power. So this is going to be x to the 2/3, all raised to the third power by itself, divided by 5, all raised to the third power. Well, when I multiply a power to a power, we learned in lesson 7.3 that when you raise a power to a power, you multiply them. So this is going to give me x to the 2/3 times 3 is just the number 2, because the 3's cancel out. Divided by 5 to the third, you can leave it as 5 to the third, or you could change it to 125, whichever one the book wants you to do. So this is probably going to give you x squared over 5 times 5 is 25, times another 5 is 125. That's how I got that. So that'd probably be the right answer for that one. Okay, part B, we're going to take this and we're going to say, okay, this is 4 squared over x to the third all squared. 4 squared is just the number 16. X to the third all squared, remember when we raise a power to a power, we multiply. So this gives me x to the 3 times 2 is 6. And there's my final answer for that. Okay, box number 6 is what I call an awesome shortcut. Whenever you are given a quotient and it's raised to a negative exponent, the rule says to do this, okay? We proceed as we would normally. This would be 1 over x over y to the positive 2 power. Because remember, if I take anything to a negative exponent, it's 1 over that same base to the positive exponent. Well, if I keep working with this, notice I would get 1 over, I would have x squared divided by y squared. That's the rule that we just learned when we raise a quotient to a power. Well, this is 1 divided by a fraction, so this, what I would do is I would take 1 over 1, this is my numerator, and multiply by the reciprocal of the denominator. This is how we divide 2 fractions. So notice all you get is y squared over x squared. So all you really have to do, the cool little shortcut here, is when you're given x over y to the negative 2, you could rewrite it as y over x to the positive 2. See that trick right there? X over y to the negative 2 can be written as y over x to the positive 2, and this is the justification for that step. And then, of course, you just end up with y squared over x squared, which is exactly what we got there. So in this example here, let me show you. I have 2x to the 6th over y to the 4th to the negative 3. I can rewrite that as y to the 4th over 2x to the 6th all to the positive 3. And that would continue on from there. So this would be y to the 4th to the 3rd, which would give me y to the 12th, all over 2 to the 3rd, x to the 18th. So my final answer would be y to the 12th, all over 2 to the 3rd is the number 8. 2 times 2 is 4, times 2 is 8. 8x to the 18th, and that's a very nice handy dandy shortcut.